So this is section 2.5. Let's check the first example. Again, it's the same thing, but now we're gonna take the continuous of the limit to the infinity. That's why it's called infinite limit, okay? I don't think so. We're gonna discuss the continuous here. Maybe. I don't know. So let's see. Consider here's the graph. What they ask you. Find the limit to the function when it's approached to which number? To the 6 from the left side. So the limit when x approach to the 6 from the left side to the upper left. And I'm telling you, you see, when they give you a graph, it's easy to locate the limit. So where is the 6? Where is the 6? I'm not asking you about the 6 because it's an asymptote. But when the limit approach the 6 from which side?
Okay.
From the left side, which is here. It goes where?
Infinity.
To the infinity. Because it keep going up. So you can put a bound to stop the limit. That means it goes where? Okay. Even if you create a table, a small table, like let's say, okay, here's the 6. From which side? From the left side. From this side. You create a table, pick a numbers here. Pick 5.999, okay? For example, pick here 5.99 and here 5.9. You will see every time when you pick a number here, the limit goes where? To like 5, for example, 509.95, okay? If you pick a number closer than 6, it's gonna keep going up. So there is no bound to stop the limit. In this case, the limit goes where? To the infinity, okay? So here's infinity. What about the next one? From the right side, you'll see the limit goes where? Here's the right side, the limit goes
Infinity.
where?
Infinity.
So also infinity. In this case, the limit when x approaches the 6 for the function is going where? To the infinity. Because we got both sides going to the same amount, which is infinity. That's mean the limit for x approaches the 6 from the left and from the right, going where? To the infinity. Okay? So that's a good point. How to graph it? There's an asymptote. This is only when you have rational. You get an asymptote. And then pick numbers here, pick numbers here, and pick numbers to the other side. Let's check the next example. That's cool. What about this one? So we have the graph. To graph it, you're gonna do the same way. You're gonna pick, here's the asymptote, which is x plus 2 equals 0. That means x equals -2. We see, here's the asymptote. -1, -2. Now, let's check the left side. From the left side, the function going where?
Oh. Negative
Negative infinity. So here is negative infinity. From the right side, the function going where?
infinity.
That's it. That how? Again, how are you gonna graph it? If there is no graph, I'm asking about the graph in this function. It's a rational function. How are you gonna graph it? You're gonna first, here's the asymptote. I found the asymptote. You're just gonna pick up the asymptote, -1, -2. Here's the asymptote. Then what I'm going to do, create a table here. Pick any numbers here. You're gonna find the function like this. Like here is -1, 0, 1, 2, 3. You're gonna get this graph. Then you're gonna pick -3, -4, -5. You're gonna get like this. Okay, that's the way to graph it. The limit goes to the infinity, goes to the negative infinity. That's it. So the limit, I'm asking you, the limit now. When x approach the negative 2 to the function equal what?
Not exist.
Does not exist. Why? Because the left goes to negative infinity, the right going to infinity. So the limit at negative 2 does not exist. But the limit on one side, this is limit on one side, the left side equal infinity, negative infinity. The right side equal what?
Infinity.
That's why it's one side limit. Okay, don't confuse yourself, it's a tangent. I have the graph, and again, you have two ways. You're gonna graph it, or you're gonna create a table. I have the graph, they ask you the limit at negative 2 from the left side. Here's negative 2 from the left side. So I'm not gonna look here, I'm gonna look only on this part. Okay? Only on this part. Here's negative 2. The limit on negative 2, when approach negative 2 goes where?
Infinity.
They're gonna put infinity here. Now from the right side, I'm gonna look to this part. The limit on the right side when approaches to negative 2, which is from this point to negative 2 goes where?
Negative infinity.
Infinity. That's it. So is the limit when x approaches the negative 2 for the function equal what?
Does not exist.
Does not exist for the function, not from the left side or the right side. But from the left side, the infinity. From the right side to negative infinity. You got it?
Got it.
Is it okay? Let's go to the next one. You do the same thing. Wow, a little bit of fun. No graph. There's no graph. So that's about, is that rational?
Yes.
Yes. So I'm gonna keep in my mind, there's an asymptote. So x minus 2. X minus 2 is going to be equal to 0. That means x equal to, it's what?
Hasn't.
It's an asymptote. 1, 2, there is asymptote. Now, I'm not gonna go to the calculator, I'm not gonna create a table, I'm gonna figure out. Tell me 2 points here to grab this part. See, I'm gonna create a small table here with x, y. Here's 2, I'm gonna pick 3 and 4. Tell me, when x is 3, how much the y? When x is 3, you're gonna plug in a 3 here. So 3 minus 2 is gonna be 1. 1 divided by 1 is going to be 1. That means when x is 3, there's 1, 2, 3. It's going to be here. Here's the point. When x is 4, 4 minus 2,
0.5.
2. Okay, perfect. 1 divided by 2 is going to be 0.5. So it's going to be here. So tell me the function look like what? 100%, this one is gonna go up, and this one is gonna keep going like this. Okay, so now I have this part, which is which side?
Right side. Right side.
The right side. So now, for the right side, when the function approaches to number 2, the function goes where?
Infinity.
I'm just gonna put infinity here. Okay, now let's graph the left side. I have here 1 and 0. Let's pick a number. We have 2 numbers. Here is the other table. Let's say here is 0.5. Let's create a table here with x, y. I can choose 1, and I can choose 0 or negative number, it doesn't matter. Okay.
Negative 1.
If you plug in 1, it's going to be negative 1. So at 1, it's going to be here. Now let's check the other one. If you plug in 0, it's going to be what? Negative, put 0 here, 1 divided by negative 2.
0.5.
So add 0 is going to be where? Here's the 0, it's going to be here. So the function See? Like this. I'm not gonna care about how it's going to be on this side. Maybe it's going to be like up or down. My important things is to see the function going where.
Towards two.
So from the left side, the function goes where?
Negative.
You got it?
Piece of cake.
Okay, perfect. Because it's a table, right? We need to figure out the function going where. There's a graph. They ask you to choose the graph, the right one. But when you plug in these two numbers in the function, check the function going where. And plug in these two numbers, check the function going where. It's right. But tell me, on this side, the function from 16 to 166. So going where?
What's an asymptote? So it's going to infinity.
You see? Because it's an asymptote, that's the main thing. So you see the function going where? If you keep choosing a number near the negative 3, is keep going where?
Infinity.
Going up. So it's gonna be going up. That's mean on this side, on the left side going where? To the positive infinity. From the left side, check going where?
Negative.
It's negative, but this number greater than this one. So the function going where?
Negative infinity.
To the negative infinity, okay? So you're gonna put here negative infinity. So it's the same thing in the table, it's the graph, okay? Let's see our graph. That means which graph you're gonna choose. First of all, the right one goes down, right? And the left one, on the left side going up. That means one up, one down. So this is wrong, this is wrong. You see, be careful. This is what? The asymptote here, x equal.
Three.
X here equal negative 3. This is the asymptote. This side going down, this side going up. You got it? So what's the vertical asymptote?
Fine.
No.
No.
How much? Hey. How much the vertical asymptote?
2.
So how are we gonna find the vertical asymptote?
T squared plus 81 equals 0.
Okay. To find the vertical asymptote, always you're gonna set the bottom part equal to 0, right? You're gonna say, okay, it's t squared plus 81 equals 0. Okay. What's the next step? Okay, how are we gonna solve?
So E equals plus or minus 100.
Okay, so first of all, how are you gonna solve it? This one.
So
You're gonna move the 81 to the other side, okay? So you're gonna say t squared equal negative 81. Okay, what's the next step?
square root.
Square root both sides. Okay, you're gonna take square root of t squared equals square root of negative 81. Next step. This one is t. I'm taking square root, so plus or minus. This is plus or minus because I'm taking square root. Now tell me how much is going to give the result. Just trying to refresh your memory, okay? So negative 81.
Keep it the same?
No, no, I have a purpose on doing that.
Oh, it's the imaginary, right?
Which one?
I9.
Oh.
Perfect. So 81 is 9 and the negative sign going out as an I. So plus or minus 9i. Can you grab this one? It's a complex number, the imaginary part. That's mean does not exist. Does not exist. Okay? You got it?
Got it.
Piece of cake. That's important. That's also important. F of x equal ln x plus 9. Is that a rational function? No, but if there's an asymptote, because there's a log, a natural log function. If there's an asymptote, yes or no? Always when you see the log function, log or ln, yes, there's an asymptote. You're gonna take x plus 9 equal to the 0, so x is going to be equal to -9. So keep in your mind, when you see the natural log or a logarithm function, okay, at one of these, you can take everything here inside and set it to the 0. So when you grab this one, you will see, yes, there's an asymptote when x equal. When x equal, okay. Go to the next example. Bingo. Is that a rational? Number 9. Don't look to the top part. It's exponential function, right? Here on the top. I need to find the asymptote. That's my goal. How are we gonna find the asymptote if it's rational?
So denominator equals
Well,
0.
well, there's 0. You're just gonna say x minus 6 equals 0. That's mean x equals 6. That's it. That is the asymptote. What about this one?
Same thing. Oh, wait, you have to simplify, right?
Okay. Before you take in the asymptote, yes.
That's the whole.
Simplify. Yeah, there's a hole. Check vertical asymptote, or you can say removable discontinuity. Yes, because this function on the top is going to be
Difference of squares.
2, 5. X plus 5 over x plus 5. You see, when you cancel these, there's no asymptote.
Oh.
It's what? It's a hole. That means it's a removable. Did not choose this.
The sign being x squared plus x minus squared.
Oh, yeah, perfect. So you just gonna choose removable discontinuity. Another question. Let's go to the next. Bingo. What? So now, what did I ask you?
If x equals -8.
Okay.
Vertical asymptote.
What vertical asymptote? So you're gonna choose this one. That's it. Okay. What about the next one? Because now it's rational, and it's not just the limb by itself. Okay. What about the next one? What about the next one? Find the vertical. What did I ask you? Oh, use the graph utility to graph the function. And I'll just find the vertical asymptote. Go ahead, use it. Tell me the limit. I'm gonna do a simple graph. For this example, in a simple graph, how many asymptotes do I have? I have x squared minus 4, 0. That's mean x minus 2, x plus 2, equal 0. So I have 2 asymptotes, which is x equal 2 and x equal -2. There's 1, 2. There's 2. And our goal is to find the limit where? To the two from the left side. That's mean the limit here. Only from this side. Now I'm gonna create a table with X, Y. You see, without using calculator. Pick a numbers here. We need to find the limit on this side. And I choose 0 and 1. There is 0, and there is 1. So when X equals 0, 0 minus 4,
It's negative 1/4.
it's negative 1/4. That's mean negative 0.25. Yes or no? See, at this point, a 0 is going to be, let's say this is the one here. Next one is 1. Like in the one here is going to be 1 minus 4.
3.
It's negative 3. 1 divided by negative 3 is that 0.3?
Yes.
Negative 0.333. Keep going. That means it's going where? 0.5 at 1 is going to be here. So the function going where? From this side going to be like this. From this side is going to be like this. Because it's going down 0.20. Oh, wait a minute. 0.25. This is not half. The function going up. Here, 0.25.
You can go back, undo. The lower back arrow.
Now, that's mean this one a little bit up. So 0.25, 0.3, there's a function going here. So it goes where?
And bigger, bigger.
Yes, you're right, because it's both negative.
So it's just mirrored.
It's both negative. That means this point is going to be here, and the other point is going to be here. That means the function is gonna go like this. On this, this case goes down. So it's gonna be negative on there. When we have negative numbers. Yeah. Now let's make more sense.